All right, in this video, we're going to go through sample question 41 from the Society of Actuaries ExamP list of sample questions. The question reads, a study is being conducted in which the health of two independent groups of 10 policyholders is being monitored over a 1-year period of time. Individual participants in the study drop out before the end of the study with a probability of 0.2, and it's independent of other participants. We want to calculate the probability that at least 9 participants complete the study in one of the two groups, but not the other. Okay, so this is somewhat of a tricky question, right? So let's say, so we have two groups, and I'll call, I'll use X for group 1 and Y for group 2. Okay, and X will be the random variable for number of participants that remain in that group. So number left in group 1. Well, Y is the number left in group 2. Okay, and we're looking for the probability that either X, the participants in group 1, that's greater than or equal to 9, while, so and Y not being, so being less than 9, multiplied by, or sorry, either this situation happening or this situation happening where X does not have 9 participants, at least 9 left, while Y does have at least 9 left. So let's look at how we're going to get this, right? So first, since these two, since the probability of anybody dropping out that's independent, what we can do is find the probability of group 1 having at least 9 people, the probability of group group 2 not having at least 9 people left, multiply that together, and we'll get this one, this probability. Do the same thing for this one. Because both groups are virtually identical, they should be, these two values should be the same. And then I add them together, right? So let's look at all these possibilities. So the possibilities that X has more than 9, as at least 9 participants left. That means X having 9 participants or X having 10. Now, this particular situation is represented by a binomial distribution. Okay, so for X, we have the probability that X is equal to 10 and the probability that X is equal to 9, right? And because Y shares the same numbers, same information, this is the exact same as the probability that Y equals 10 and the probability Y equals 9. So you should be familiar with the formula for a binomial random variable. If you forgot, it is the following. Probability that X is equal to some specific X, that is n, number of trials, choose X, multiplied by the probability of a success, P, raised to the X power, multiplied by Q, or P minus 1, raised to the n minus X power. So for here, 10, choose 10, right? The probability of remaining in the group multiplied by the probability of success. I'm defining success as remaining in the group. So this is 0.8 raised to the 10th times 0.2 raised to the 0. And this is 10 choose 9 times 0.8 raised to the 9th times 0.2 raised to the 1st. Okay, and we'll get these probabilities right now. So let's see. 10 choose 10 times 0.8 to the 10th that's equal to, and then times 0.2 to the 0, it's equal to 0.10737. And the same information here. Let's see, 0.2 to the first. And that's equal to 0.2684. And I add these together to get the final probability that x is greater than or equal to 9. Which is going to be 0.37580. And I'm going to use this quantity quite a bit. So I'm just going to, I always write a note to myself sometimes. STO x. That means I'm just using my calculator to store this as the variable x there so I can continuously use it in different problems. All right. So, like I said, since x and y are virtually identical, this also happens to be the probability that y is greater than or equal to 9. Okay. So the first situation that we're dealing with here is x being greater than or equal to 9 and y being less than 9. Now, the probability that y is less than 9, I could do this, right, for 0, 1, 2, 3, 4, 5, 6, 7, 8. That would be annoying. Y being less than 9 should be the same as this. 1 minus y being greater than 9, greater than or equal to 9, which I have here. So I'm going to have, and this is why I stored it, 1 minus x. That's going to be 0.6241, right? So I multiply those two values together, this 0.3758 and this 0.6241. So now I get 0.2345. Now what this is the probability that x has at least 9 participants left and y does not. Now this needs to be added to the probability that y has at least 9 participants left and x does not. Now again, as I mentioned before, they're identical. So this is also 0.2345, which in the calculator I can just multiply by 2. And I get 0.469, which lines up with answer choice E. Okay, so this has really just been an example of binomial random variable, right? Nothing too complicated. So I can't stress enough how important it is to know the following things about not just the binomial random variable, but both the discrete and continuous random variables. Binomial is going to be one of the more important discrete ones, right? So know the probability, know the expected value, know the variance, know the moment generating function. Admittedly, I don't recall moment generating functions for discrete random variables showing up that often, although I would definitely know it for stuff like exponential or gamma or something like that, right? But yeah, hopefully this video helped you out. If it did, hit the like button, subscribe, that definitely helps me out. If you want to see more stuff like this, I got a playlist. More questions worked out. Other than that, good luck, guys.